Okay, we're moving on to simplifying and evaluating algebraic expressions. This is that's numbered section 4.R.2. Okay, and so we're talking about algebraic expressions specifically. These are things that look like this. So, for example, they look like 5x plus 3. Okay, it's an algebraic expression. It represents some unknown quantity. We just don't know what that number happens to be, right? But if you were to say, plug in a number right here for x, okay, say x is equal to 1 or 2 or something like that, well, then you can actually figure out what this is equal to. Okay, but for now, let's talk about some terminology. So first of all, I see 1, 2. I see 2 terms. Okay, algebraic expressions tend to have multiple terms. Sometimes only one term, but in this case we have 2. As far as how we identify the terms, okay, we're just going to call this one on the left the first term, and the one on the right we'll call the second term. Okay, yada yada yada. Let's go and get this out the way. Okay, and you'll see in Hawks they ask a question about these terms. Okay, so for the first term, the question that they'll ask is, what type of a term is it? Okay, the first term, what type of a term? Is it a variable term? Variable term? Or is it a constant term? Okay, well actually we have one of each here, so let me just label them. The first term, the term on the left, it has an unknown, right? It has a variable, so we'd call that term 5x, the variable term. Okay, the other term, this positive 3 right here, does not have an x, right? So it is just going to be a constant term. Okay, and so constant terms are just a number, no variable associated with it. But a variable term has 2 parts. It has the first part, which is called the coefficient. That's the number part. The number part, so in this case 5. And it has the actual variable, which in this case is x. Okay, so a coefficient is the number that's in front of an x or a y or any other letter or any other variable. Okay, so there we go. We have terms, we have variable terms, constant terms, coefficients, and variables. Okay, let's go on to another example. Less definition, more working it out. Okay, so example 2. On this one, we want to evaluate the expression negative 5x minus 2y minus 1. And we'll say we're evaluating for when x is equal to 2 and y is equal to 4. X is 2, y is 4. Okay. So what does this mean, right? Evaluate for when x is 2 and y is 4. Well, that means take this expression and figure out what it will equal if I substitute in 2 for x and 4 for y. What does that look like? Negative 5. I'm going to leave parentheses as a blank where x was, minus 2, parentheses where y was, minus 1. Okay, so I'm using this as a frame, and I'm leaving spaces so I can substitute in these values for x. Okay, so we said x is 2. Okay, well, I'll plug in 2 where x was. And we say that y is 4, so I'll plug in 4 where y was. All right, so now this is just an order of operations type problem, right? We can ignore this altogether. This is what I'm focused on. Okay, I don't want to leave all that up there though. Okay, so order of operations. Do I have any parentheses? I do, but these parentheses have nothing going on inside of them other than a number. I can't do anything in there, so I'll just move on. Parentheses out of the way. Exponents or roots, I don't have any of those. Then I move on to multiplication and division from left to right. So from left to right, going this way, I need to decide if I can multiply or divide. And I see multiplication here, right? There's nothing in between right here, so I know that indicates multiplication. Negative 5 times 2, negative times a positive is a negative 10. Okay, here I have negative 2 times positive 4. Negative 2 times 4 is a negative 8, and then minus 1, right? Just bringing that down on the end. Now I have negative 10 minus 8 minus 1. Well, negative 10 minus 8 is negative 18. Bring down my minus 1. And negative 18 minus 1 is negative 19. So that would be my answer, right? I've evaluated the expression for when x is 2 and y is 4. Okay, we should do another one like that. Okay, example 3. I want to evaluate the expression negative 2x squared minus 5y squared minus 1 when x is negative 4 and y equals 0. Okay, and I like to color code these a little bit, so we'll call this one the red one and this one is the blue one. Okay, so I'm going to rewrite the expression just like I see it, except with blanks, parentheses, right, where the variables are. And then I'll plug them in. So for where x was, I'll put in negative 4, and where y was, I'll put a 0. I love substituting in 0. It usually cancels stuff out, makes things easier. Okay, so order of operations, I look inside the parentheses first. When you're just substituting numbers in, you're not usually going to have anything to do inside of the parentheses. Okay, those are just there because you needed to have a placeholder for where those variables were. All right, and then next thing would be exponents. I can square negative 4, right? Negative 4 times negative 4 is a positive 16. So this becomes negative 2 times a positive 16. 0 squared is 0. Minus 1. All right, exponents, done with that. Don't have any roots. Going on to multiplication and division from left to right. So first multiplication I see on the left is negative 2 times 16. I can multiply those two together and get negative 32. Multiplying 5 times 0, I get 0. So this actually just cancels out. I could have canceled out here if I wanted to. They cancel out. So I'm left with minus 1. Negative 32 minus 1 is negative 33. Okay, that's not too bad. Let's do another one. Fourth example, we have x plus y squared, those two together squared, plus 2z. And I'm going to substitute in x is 3, y is negative 2, and z is negative 7. Okay, cool. So we have 3 variables this time. So we'll plug them in. Leave myself some spaces here. We're going to use red for x, so that's a 3. I'm going to use blue for y. That's going to be a negative 2. And for z, let's use green. Negative 7. Okay, in the parentheses, I can actually do something, right? 3 plus negative 2. Remember, if you have the double signs, that just means look at the double signs. If they're the same, right? If they were both a plus, then this would be a plus. If they were both minuses, it would be a plus as well, right? If they're the same, it's a plus. If they're different, like in this case, we have a plus and a minus. If they're different, then you change it just to a single minus sign. So that's 3 minus 2, and we all know that. We've been doing that forever. 3 minus 2 is 1. So we have 1 squared plus 2 times negative 7. 1 squared is 1 plus 2 times negative 7. 2 times negative 7 is negative 14, so this plus becomes a minus 14. And then finally, 1 minus 14 is negative 13. There we go, negative 13. All right, let's move on. Example 5. We have 2 times b minus 5 minus 4 times b plus 5, and we want to evaluate this expression when b is negative 5. All right, so we're just going to go in and plug in negative 5 for b. Okay, negative 5 minus 5 is negative 10. Negative 5 plus 5 is 0. 0. I like when 0 happens. Okay, so the reason why I like 0 is because that's going to multiply together and be 0. So at that point, I'm just going to ignore that term altogether. 2 times negative 10 is negative 20. Okay, so maybe you noticed you can actually work each term by themselves. So let's go back to the previous example for a second. Notice how we kind of went the long way on this one. Maybe you noticed that and maybe you didn't. But notice this 2 times negative 7. See how we just kept bringing it down? We could have multiplied that out in the very beginning. Okay, it's a separate term, so you actually can handle separate terms on their own. Okay, so I could have gone straight to 1 minus 14, and that would have actually saved me some trouble. Okay, keep that in mind. It's a good skill for algebra. Okay, moving on. Let's see, what's our next problem? All right, so, okay, what we've been focusing on is evaluating expressions given a number for the variable. Let's now decide, or let's work out problems where we're not given a number for the variable. We just want to simplify the expression. Okay, so that's going to be the instructions here. Simplify the expression. Okay, so the word simplify means you're not going to substitute anything in. You are just going to try to write this as condensed as you possibly can. All right, so we need to talk a little bit about combining like terms and what constitutes a like term. Okay, so negative 5x plus 8x, they both have an x. And those x's have the same exponent. They're technically understood ones, right? There's nothing there that means, the exponent just means that you have one x that's sitting right there being multiplied times a coefficient. Okay, so you have x just sitting there for both of them. They're like terms. Okay, they're like terms. Okay, so in that case, I can just work out this part, negative 5 plus 8. That's 3. Negative 5 plus 8 is 3. So this is 3x, right? So you combine two like terms that are alike, right? They have the same variable, the same exponent, and you can put them together as one. Think about that. You are down 5x's, and then you add 8x's. Now you are up 3x's. Okay, that's how that works. Let's do another. Example 7. Negative 3x plus 4x squared minus 1 plus 3x squared. Okay, for this one, I see multiple terms that have x, right? But they're not all alike. Well, which ones are alike? This positive 4x squared and this positive 3x squared, right? They're the same variable with the same exponent. So I could put those two together. 4x squared plus 3x squared is 7x squared. Okay, well, what about the other ones? This negative 3x, for example. There are no other terms that match up with that one, so I'll just have to bring it down. It's still there, but I can't combine it with anything else, so I'll just bring it down. As far as this minus 1 right here, well, there are no other constants. Remember, constants are just numbers without a variable attached to it. There are no other constants, so it's still there. So 7x squared minus 3x minus 1. Okay, let's do another one. Example 8. X plus 3y minus 5x. X plus 3y minus 5x. Okay, so you need to be careful with this one. Remember, there is an understood 1 that sits in front of any variable that's not that does not have a coefficient in front of it. Okay, it's always understood that it's 1 times that value. Okay, so now think about that for a second. I do want to point out a mistake that I see pretty often. People will often think that they're saying there's a 1 in front of the x, but what they end up actually saying is that x is 1. Right? That is not true. X is not going to be 1. I mean, it could end up being 1, but chances are it's not. Okay, x is not 1. There is a 1 in front of the x. The reason why that's important is because this becomes 1x minus 5x. Those are my like terms. And we know that 1 minus 5 is negative 4. So that's negative 4x. And then this plus 3y just has to kind of go along for the ride because there are no other y's to pair it up with. All right, example 9. Okay, let's simplify. 8x minus 6 plus 2x minus 4 plus x. Simplify that. Okay, I see several like terms actually. So here we have positive 8x, positive 2x, positive 1x, right? There's an understood 1 there. 8x plus 2x plus 1x. 8 plus 2 is 10, plus 1 is 11. So we have 11x. There's this constant minus 6, and there's this constant minus 4. So read that as negative 6 minus 4. Negative 6 minus 4 is negative 10. So 11x minus 10. All right, we're running out of examples here. Let's go on to example 10. We have 2x plus 3y squared minus 3 minus y squared plus x minus 3. Okay, kind of got a lot going on there. So let's go ahead and try to look through and see if we can find any like terms. The first one I see would be a positive 2x, and we underlined it, positive 2x and a positive 1x. 2x plus 1x is 3x. Okay, next I see positive 3y squared and negative 1y squared. Notice I'm taking the sign that's to the left of it, right? That's actually telling you if it's a positive or a negative. So I'm including that plus, I'm including that minus. That's important. Okay, so 3y squared minus 1y squared. 3 minus 1 is positive 2. So positive 2y squared. I have the constant minus 3. Another constant minus 3. So we're going to read that as negative 3 minus 3. Negative 3 minus 3 is a negative 6. So we have 3x squared plus, 3x plus 2y squared minus 6. All right, I think we have 3 more examples. All right, so negative parentheses 4x plus 3, close parentheses, minus, open parentheses, 3y plus 3. All right, so here we go. These are a little different because we are introducing parentheses. In other words, we have things that are grouped together, and we need to be able to break them up. We're going to use the distributive property. So I think the easiest way to see this is to read this minus sign here as a negative 1 that's in front. And then we're going to have to distribute that negative 1. Negative 1 times 4x is negative 4x. Negative 1 times a positive 3 is a negative 3. Over here, we have a negative 1 in front of the parentheses. Negative 1 times 3y is a negative 3y. Negative 1 times positive 3 is a negative 3. Okay, so see how that transformed the problem from a slightly more complicated problem to a little bit easier problem. Now we're just looking to combine our like terms. Well, I'm looking at this negative 4x first. I don't see any other x's, so I'm just going to have to bring that down. I'm looking at this negative 3y and see that I have another negative 3, a constant, and I see I have another constant, negative 3, so I'll put them together. Negative 3 minus 3 is negative 6. And then this minus 3y, there are no other y's, so I'm just going to have to bring that one down, negative 3y. So negative 4x minus 6 minus 3y. All right, let's go on to 2 more examples. Example 12. Three, open parentheses, x squared plus 3x plus 2, close parentheses, plus 4, open parentheses, x squared plus x plus 1. All right, so this problem here, very similar to the last one. We're going to distribute 3 times x squared is 3x squared. Notice I'm not trying to combine any like terms until I get rid of all those parentheses. Okay, that's something that you have to do. You cannot combine, let's say, this constant with this constant, because this is not really a 2. That's really a 3 times 2. Okay, anyway. 3 times 3x is going to be a positive 9x. And 3 times 2 is a positive 6. Positive 4 times x squared is a positive 4x squared. Notice how when I say positive, I put a plus. If I say negative, I put a minus. 4 times x is a positive 4x. And 4 times 1 is a positive 4. All right, like terms. Here we go. Positive 3x squared, positive 4x squared. 3 plus 4 is 7, so we have 7x squared. Okay, I'm done with those. Positive 9x, positive 4x. 9 plus 4 is 13, so positive 13x. Positive 6, positive 4, both constants. 6 plus 4 is a positive 10. So 7x squared plus 13x plus 10. Okay, that brings up our last example, and this one's a fun one. Example 13. Go figure, 13, right? The luckiest number, or unlucky, whatever. Negative 9x minus x over 2 plus 8x. All right. This one looks kind of weird. Remember, fraction bars like this one here basically means that you do those like they're in parentheses. So I'm going to focus on that first. Negative 9x minus x. Remember, there's an understood 1 here. That's a negative 1x. Negative 9x minus 1x is negative 10x over 2 plus 8x. Now I see division right here. In order of operations, say I need to take care of that before I do anything else. So negative 10x divided by 2 is negative 5x. Bring down my plus 8x. And that should look kind of familiar. Negative 5x plus 8x is going to be 3x. And there we go. Okay, so That we covered a lot there, right? Let me kind of recap real quick the topics that we talked about. We talked about terms, specifically variable terms, which includes a coefficient and a variable. We talked about constant terms. These are terms with no variables, just a number. And we talked about simplifying expressions, algebraic expressions, which just means to combine like terms. And we talked about evaluating expressions given the values for the variables. Okay, and that's whenever you get a number for an answer. Okay, so that's simplifying and evaluating algebraic expressions.